So in this video, I'm just going to be talking a little bit about actuarial life tables, and actually what they are, why they're useful to actuaries, um, and some of the basic principles in terms of the calculations that actually goes into actuarial life tables. So first and foremost, we need to look at the basics. So as you can see here on the left-hand side, I've got this L0, sorry, which equals 110,000, and that is 110,000 lives, okay, in our life table. And typically L0 will start around 100,000, around the 100,000 mark. So for this purpose, for this video, I've just gone with 110,000. And we can denote in general that LX is the number of original lives age 0 who are still alive at age X. So for example, if you look there, I've written L40. So that would be the number of lives that are alive aged 40 from the original 110,000. So, and that 110,000 is just like the sort of sample we've got, that we're going to build our data from in terms of actually constructing our life table. Over on the right hand side, you can see DX, which is a number of original lives aged 0 who are still alive, or who have died, sorry, not still alive, I should say died, who have died at age X. So, for example, D20 is how many people have died at the age of 20 within our life table. So on the next slide, I'll show you a bit about how we actually construct a life table itself. As you can see, we want to look at the relationship between LX and DX that we just looked at on the previous screen. So, for example, if we want to find in general LX plus 1, it will be LX minus DX. So if we wanted to find, let's say, for example, the number of lives still alive at age 21, we would do the number of lives alive at age 20 minus the number of lives that have died at age 20, and that would give us the total number of people who are still alive at age 21. So if you can see this in action here on the right hand side, with this small sort of tabulation I've done of an example life table. So again, we're starting with L0 at 110,000, and at age 0, 1,000 people die. So then L1 becomes 109,000, and then 2,000 people die at age 1. So L2 becomes 107,000, and so on. And of course, we do tabulate these entire life tables up until there is no one else still alive. So we typically denote that with a W. And we know for a fact that LW will always equal 0, because obviously eventually everyone will unfortunately die. So yeah, that's a little bit about the basic sort of relationship between LX and DX. Finally, just a quick look at some of the probability functions that you can actually produce from life tables. So NPX is the probability of a life aged X being alive in n years' time, and we find that by taking the number of lives that are alive at Lx plus n and dividing it by the number of lives alive at Ln. So like I said, NPX, for example, it could be, let's say if it was 5p10 would be the probability of someone aged 10 still being alive in 5 years' time. And similarly, NQX is the probability of a life aged X dying within the next n years. So for example, if we had 5Q20, it would be the probability that someone aged 20 will die within the next 5 years. And also there, just a little bit at the bottom, briefly, the sum of NQX and NPX is equal to 1. And that's an empirical fact, and that is very important in terms of the construction of our life tables. So that's it for this video, just a little quick introduction there. Yeah, thanks for watching. Bye.